Okay, so here we go. So, number one, sketch a normal curve for a set of data that has a mean of 12.5 and a standard deviation of 2.5. Okay, so any of these questions may be on the test, right, or ones like them. So, would you like me to take one? You're sure? So, if you understand how to do all of these, right? Because I'm working through these with you, right? You're not, I mean, if you want to, you can work ahead of that. That's fine. But I'm going to show you each of these, right? Just as an example. You're going to be asked ones like this on the test. In addition to that, you're going to want to do the stuff that's on the sheet, right, for the review. This isn't going to take terribly long, so you should have a reasonable amount of time. Okay, so we've got a little thing here, right? So we could say, well, okay, so normal curve looks like this. Except I slide it over a bit. Do that. Clear that. Move it over just a touch more. Okay, so we'll go. That's the mean of 12.5 in the middle. What's out here? 15. What's next? 17.5. What's next? 20. What's down here? And then that's it. Okay? Seriously, that's it, right? So just put the mean in the middle, you add standard deviations as you go up, and you subtract as you go down. If each data value in number 2 is increased by 2, where's number 2?
It means number 1. I'm pretty sure.
Yeah, pretty sure it means number 1. Okay, so we've just got edits all over the place here. If each data value number 1 is increased by 2, what does it mean? 14.5. Okay. And what's the standard deviation? 2.5, right? So what that would do basically is slide this over by 2. Right? And it would slide this over by 2. And that would become, but the shape would stay the same. Right? And the shape is what determines the standard deviation, right? It's the shape of the curve. Sketch the new curve. Okay, where's our middle? So that would be 14.5, this would be 17, 19.5, and 21.5. And going down, this would be 12, and 9.5. Yeah.
That's supposed to be 22. So the last one is 22.
Right. Thanks. 22 and 7. Okay. And if you got the normal distribution, then something like that. Right? But standard deviation remains the same, right? So if we decided, hey, yeah, this test was a little hard, we're going to add some marks, which we would never do, by the way. But if we did decide that this test was a little hard, we're going to add some marks to everybody, it would not change the shape of the distribution. I mean, certainly if we are going to change something, we might say, this was too spread out. Too spread out means it has a really large standard deviation. So we're going to tighten it up, right? We'll make the standard deviation smaller. So, you just imagine you've got a more spread out distribution, right? So you got a distribution looks like this as compared to this. Larger standard deviation, right? More spread out, larger standard deviation, tighter to the mean, smaller standard deviation. Okay? We might take a distribution like this and make it into a distribution like that. We would use the z-score formula. Okay, and what we would do is calculate everybody's z-score, because the z-score is where are you relative to the rest of the class. And then we would change the mean and the standard deviation, and we would recalculate your x value. So we would go x is equal to z sigma plus mu. Right? That's just a rearrangement of that formula, which sometimes we'll do in solving a problem. And I would say, okay, what we did is we calculated all your z-scores. I wrote down everybody's z-score so we know where you are relative to everybody else. And now I'm going to take that, multiply it by the new standard deviation, and add the new mean. Okay? And that way it keeps you in the same position, but it adjusts your mark. Okay, and that's the way that they would do things provincially. If they were going to change things around, they would do something along those lines, right? Okay, a new set of data has the same mean of 12.5 but a standard deviation of 1.5. Describe how the graph would compare to the graph in number 2. So, just describe it in words. What would it look like? Okay, I'm tighter to the mean. Okay.
Tighter to the mean. Who made this review sheet?
I don't know, not me. Okay, so we'd end up with a graph that looks like the green one there, right? You get. I guess the thing would still be the same height though, so. But it would be a tighter distribution, right? It'd be closer. So narrower, right? So the wider the distribution, the greater the standard deviation, the tighter the distribution, the less. So tighter around the mean, you know, closer to the mean. Which of the following sets of data would be normally distributed? Okay, so here we've got observations, right? Interval from 100 to 120. Now remember, when we give you intervals, it includes this, right? So it includes the lower number and does not include the upper number, right? So if you're doing the tallying and you say, oh, I give it 120, it goes in here, not in here. Okay. Now, one way to get around that is maybe we list this like this: 100 to 119, 120 to 139, and so on, right? And then this one ends up as like 200 to 219. Okay. And that's the way you do it. Then it's there's no ambiguity, right? There's no, I can remember where this goes. Okay. So if you get a tally chart, maybe we'll give you numbers like this, and then, okay, it's kind of obvious where everything goes. Okay, so which of these is more likely normally distributed? Number 1 or number 2? Number 1, why?
Bigger in the middle, smaller in the end.
Yeah, bigger in the middle, smaller in the ends, right? So we got large middle, got little on the ends. This one's just pretty evenly distributed, right? 4, 6, 6, 5, 6, 4. Okay. So this is pretty evenly distributed, even. This is more normally distributed. Okay, there's more data in the middle, small in the ends. That matches up with a normal distribution curve. This guy here would just sort of look like that, you know. Might be some little, you know, if you drew a histogram of it, kind of like that, just a botched up histogram of it. Manufacturers offers a warranty on its TVs. The TVs have a mean of 6.5 years with a standard deviation of 0.8 years. I'm guessing that's life. For how long should the TVs be covered by the warranty if the manufacturer wants to repair no more than 2.5% of the TVs? Okay, so any normal distribution type of question, sketch out the distribution, right? Because you want to be able to label this, shade this, then figure out what it is you want to do, right? And I'll put this up so if you want to see the rest of it, it'll be online. So mean is 6.5, and the standard deviation sigma is 0.8. That's all in years, right? So that x-axis really is an axis, right? There's no y-axis on here. It's sort of, you know, just going up the side is frequency, right, or likelihood of stuff happening. That's measured in years. If they gave you years and months, you'd have to convert the months into years, right? So if they said 6.5 years and 9 months, 9 months would become 9 divided by 12, or 0.75 years. For how long should TVs cover if the warranty manufacturer wants to repair? No more than 2.5%. So they're giving us an area, right? 2.5%, which is 0.025. Remember, areas for us have to be decimals. What we want to find is the value here, okay? And what we're going to use is inverse norm, right? So an inverse norm, you are going to give it the area to the left, which is 0.025. You give it the mean, and the standard deviation. Now, if this is a standard normal distribution, these guys will just be 0 and 1. On the 83s, you don't have to enter a 0 and 1. Okay? And on these guys, where's my calculator? Okay. So on these guys, if you have the menu, so number, no, I don't want that. I want number 3, inverse norm. Okay. Clear. Quit. We're going to quit out of that. Go back. Distribution. 3. Inverse norm. The area. Now, if you want, you just go 2.5 divided by 100, right? Say it's 2.5%. Put it in as 2.5 divided by 100. It'll convert it. The mean, 6.5. Standard deviation, 0.8. Say paste. Okay. If you're entering yourself, then this is what it's going to look like. Inverse norm. 0.025, comma 6.5, comma 0.8. Hit enter. 4.93. So 4.93, yeah, so TV is covered by the warranty. The manufacturer wants to repair no more than 2.5%. So 4.9 years. So we got a little rounding issue here, right? If I go to 5 years, then I'm going to be doing more than 2.5. If I just want to offer the warranty in years, then I'd have to go to 4 years. If I want to offer a 4.9-year warranty, then I could do the warranty in months, right? Because we could do 0.9 years is 0.9 times 12 is 9.8, right? Or 10.8, so then we could just say 11 months, 4 years, that would be 48 plus like 59 months or 58 months. Because you're not going to offer warranty, say it's 4.9 years, right? No, but you could say we're offering a 58-month warranty. Okay. And then the question I would ask is, all right, what if it was a 5? Like, what percent of them would we be repairing, right? Because we don't want to advertise and say we're for 4.9 years. Nah, okay, that doesn't sound right. So to find out what it would be if there were a 5, we'll go normal CDF. So now we're looking for this area. We don't know the area. And we would say -1 E99, okay, so left tail. So when you're using normal CDF, you're either going from the left up to a number, so it's -1 E99 up to the number. You're going between two numbers, that it's lower and upper, or you're going from a number all the way to the right, in which case it's the lower bound and then 1 E99. Now we're going to give that to you on the formula sheet. It'll specify how to enter this, okay, and you should have practiced enough. So the question we're asking is, what if we offer a 5-year warranty? What percent? So -1 E99, that's nice on this calculator, right? It comes out, because that's what I wanted. The upper one was 5. The mean was 0.65, and the standard deviation was 0.8. Paste that in, and we'll say, all right, what percent? So 0.03. To get the actual percent multiplied by 100, 3.04%, and they might say, okay, we'll take the extra 0.5%, right? A lot of people, by the time 5 years is up, if the TV dies, they're just going to trash it anyways and just, go buy a new one because it's got more bells and whistles now. Okay, so 3.04%. Okay, so if we did offer a 5-year warranty, we would be repairing, and they don't even repair that stuff anymore anyways, right? They'll just give you a new one. It's honestly not worth it because the time for somebody to sit down and diagnose the thing is just easier. You got to pay that person and then maybe it can be repaired or not. So we live in a throwaway society. Data below are final exam marks in a class of 30 students. State the mean, the median, and the standard deviation. Okay, what do we got to do with these numbers? Got to put them in our calculator. We're going to make you do 30 on the test? No, we'll make you do 20 on the test. Okay? Check the numbers as you enter them, right? Because you're going to get everything wrong if you slip, right? So if you entered a 6 instead of a 60, it's like, yeah, it's not going to be good, right? Okay, so I'm going to pause this. Okay, so a little tedious. We've got 30 numbers in that. How do I know I've got 30? Because you notice now it says, what's the 31st? Okay, and actually I didn't have 30. How did I know I didn't have 30? Because it was asking me for the 30th number. Okay, so now we'll check, right? So we want to go to stat, calc, one var stats, right? And that's all we want, because all we have is the data in list 1. So frequency list, leave it blank, say calculate. There it is, we got the mean. What's the mean?
71.2.
71.2 or 71.17. So let's do this. If rounding is not mentioned, let's round to 2 decimal places. Okay? So if rounding is not mentioned, well, do you have your set to round to 1 decimal? Or? It is 71.2 as 1 decimal place, but as 2 decimal places, it's 71.7. 17. What's the median?
71.
Okay, so to find the median, we got to scroll down, right? Median is 71.
What is the median?
What's the standard deviation?
11.6306.
Yeah, it's 11.63. Okay, so you need to know how to do all of this, right? Put a set of numbers into a list, run the one variable stats, and state the stuff. Create a frequency table using sigma as the interval width. Okay, so I'm not going to use 11.63 as the width, so I will use, let's say, 10, right? So we'll be close to the standard deviation, but not exact. Okay, so to do a frequency table, we're going to have intervals. What's the lowest mark in here?
50. Oh, I have no idea.
Looks like 51, right? What's the highest mark is 9. So we need to go from 50 to 100, right? Okay, so we're going to set this up, and we will go from 50 to 60, 60 to 70, 70 to 80, 80 to 90, and 90 to 100. Okay, now you might also see it written as 50 to 59, 69, 79, 89, 99.
That's a lot easier.
I don't like this.
In which case, let's say 100 to 109, right? So, you know, you could see it different ways, just be prepared, right? On the test, maybe you see it as 50 to 59, maybe you see it as 50 to 60. I'm going to go back to the other one. So 50 to 60, 60 to 70, to 80, to 90, to 100, right? Include, exclude. So any mark up to 60, if you had a 59.5, you would put it in here. But if you had a 60, it would go in that one. Okay, now to do the tally, basically go through the list. So I'm going to get the list in my hand. Well, I'm going to shrink this a bit, is what I'm going to do. So view, zoom, and let's take it down to say 150%. Okay, yeah, there we go. So when I find tally, I'm just going to go through and say, okay, 51, I'm going to cross it off so I know I've done that one, right? Then 86, that goes in here. 72 goes in here. 60 goes here, right? So 60 goes in the one that starts with 60. 71, 72, 71, 72, 71, 73, 71, 73. So when you've got 4, then you put a stroke through to indicate the 5th. Okay, just make sure that's how we do it. Tally is usually 1, 2, 3, 4, and then a stroke for 5. Okay, 80, 80, 80, 80, 2 80s, 74, 63, 74 and 63, 88, 68, 64, 88, 68, 64, 97, 81, 65, 53, 65, 71, 53, 65, 71, 60, 67, 94, 62, 82, 54, 85, 57, 69. 57 and 69. Okay, then we count these up. What should they add up to?
30.
They should add up to 30, right? So if they don't, then you have problems. You got to go back through and see. So 7,
13.
Okay, so we got 9, 16, 20, 30. Good. Okay, if they don't add up to 30, you made a mistake somewhere. Right? And then you got to go back and, I mean, if I'd done that, I would just go back and just sort of count through, say, I think there's 4 of these. Are there 4 of them?
You made a mistake.
Where?
There's 2
It's
90
410,
to
7,
100
7,
and 7 80 to 90.
Ah,
7, 7.
right.
Yeah.
There we go. Okay, so it's handy having a bunch of us here to fix that. Okay, so this is 7 and that's 2. All right, you don't have that on a test, right? So you just need to be a little more careful if you're doing a tally chart. Okay, so we can start here. This would be 50, 60, 70, 80, 90, 100. If that goes 50 to 59, you still list it just this way, right? 50, 60, 70, 80, 90, 100. Frequency, 1, 2, 3, 4, 5, 6, 7, 8. So we're going to go 2, 4, 6, 8, 10. 50 to 60 is 4. Draw a bar across to there. Even if it says 50 to 59, do the bar like this. 60 to 70, whoops, go up to 10, cross, down. If you have a ruler, it's nicer, you know. 70 to 80, we got 7 of them. 80 to 90, we've got 7 of them. And 90 to 100, we've got 2 of them. Okay? That's a histogram, right? Histogram, bar graph, the bars are joined. So even if this says 50 to 59, 60 to 69, you're still going to join the bars, right?
That wouldn't be bell shape, right?
Frequency polygon, you put a dot in the middle of each of the bars, right? Because what we say we're doing frequency polygon, we're saying we want the middle of that interval. Like we've lost, the frequency chart loses the individual numbers, right? We don't know what these two numbers are, right? They're 94 and 97, but we don't know what they are anymore. We don't know what these were. We know they're between 80 and 90, but we don't know what they are. They could all be 80. Could be 80, 80, 80, right? But we let the middle of the interval represent the interval. So now this says there's like 295s, there's 785s, there's 775s, there's 1065s, and so on, right? So you lose a little something, but if you've got a large enough amount of data, it really isn't that, you know, they will average out to the middle. It's not going to happen as much here. It's a small amount of data. But if you do this for 10,000 tests, right, so provincially, they put out a history and say, yeah, you know, like there's enough marks in any one interval that the average probably is pretty close to the middle. Okay, frequency polygon, you join these guys with straight lines. Okay, don't tail it out. Okay, so you join those guys with straight lines, you get a frequency polygon. Okay, so on the test, you got to do a tally chart. You know how to do a tally chart. You have to take tally chart, make it in histogram. We can do that. We got to draw a frequency polygon. We can do that.
Which is the one called where you is the bell?
That's called normal distribution. Is this data normally distributed? Yeah, not greatly, right? It's a little too high in this end. If we had 10,000 people, we're going to get closer to normal distribution, right? The more the data, the more that you'll get. The heights of 200 grade 8 girls is normally distributed with a mean of 120 centimeters, a standard deviation of 10. How many of these girls are more than 140? Sketch. Okay. Now, some of the questions will say, draw a sketch. Show the calculator input that you're going to use, and then give the answer. Okay, so read the question. Some of them won't. It might just say state. It might be a multiple choice question. It just says state this, right? Like I don't care how you got it. You should still do all this work. Okay, so mean of 120. And a standard deviation of 10. Well, they're grade 8s. Okay, those actually have units, right? It's 120 centimeters, but yay. And a standard deviation of 10. How many of these girls? Where does 140 lie in this distribution? To the left? Yeah, to the right, right? And it's actually a couple of standard deviations out, right? Okay, if that's 120, one standard deviation is 130, two standard deviations. So we know from the chart, right? Like we have remember we did the one with the chart and it said that there's this much percent. So this is really about 16%, I think, that's out here. or something like that, 14, 15, 16, right? Of course, but we got a calculator to do this for us, so normal CDF, right? Because we're looking for an area, right? We're actually looking for how many of the girls, right? There's 200 of them, so normal CDF. So we want from 140, that's my low bound, okay? So shade this in, okay? That's all part of it, up to 1E99 with a mean of 120 and a standard deviation of 10. Okay, so putting that back on.
What order you put?
Yeah, there's the right order, and then there's the I'm going to get it wrong order.
So my order.
So lower 140, upper 1E99, mean what's mean 120, and a standard deviation of 10. Okay, so if you're using this kind of calculator that's showing you this stuff, make sure the numbers are good. If you're using the other calculator, you're going to enter that. Normal CDF, 140, 1E99, 120, 10, right? You get anything in the wrong order and it's just wrong. Okay, yeah, there's no option there of. Okay, so the probability is, or the area under the curve is 0.0227. As a percent, it's 2.227. But we want to know how many out of 200. So we go times 200 equals, we got 4.55, so we'll say 5.
Why did you times by 200?
To
find out the number of girls.
Yeah, you're finding out the number of, right? So questions that can be asked with a normal CDF, right, or a distribution. What's the area? 0.0227. What's the probability? 2.27%. Right, or what's the percentage? What percent of girls? And then what number of, in which case you just take this. Okay, now if you want to write it down, you could say that's equal to 0.227, what is it, 0.0227. So 0.0227 ... right? So you say that's that, right? And then just go something like this times 200. Is 4.55, so 5 girls. Okay, so about 5 girls, right? I would say 4 to 5, right? These are all, anytime you're doing the normal CDF, it's approximations, right? So it comes out like 4.5 girls, you'd say 4 or 5, right? Like we expect 4 or 5. I wouldn't be surprised. If it was 4, it's not like, but it said 4.55 and that's 5. No, it said 4.5, right? We don't have half girls, so, well, if we do, they're really short. They're on the far end of they're on the left end of the distribution. Okay, we don't have a half of a student or anything like that, so,
You can make one.
yeah, we could, but that's just a trick. They don't actually cut them in half. All right, and that's that.
Oh.